Welcome to another physics class. The topic before us today is dimension. Dimension in physics simply means the power to which the fundamental unit of mass, length, time, temperature, etc. must be raised to represent physical quantity. The power to which the fundamental unit of mass, length, time, temperature to measure but few must be raised to represent physical quantity. Or in another way, it can be taken as this: the number of times that the fundamental unit of mass, length, time, temperature appear in a physical quantity. To write dimension, simply means the power to which the fundamental unit of mass, length, time, temperature, etc. must be raised to represent physical quantity. That the fundamental unit of mass, length, time, temperature, etc. appear in physical quantities. Now, the next is application or uses of dimension. Application or uses of dimension. 1. Dimension is used to determine the dimension and unit of physical quantity. That is used to determine the dimension and the unit of physical quantity. At this point, don't forget, we discussed lengthily on this physical quantity in our former lesson. And we mentioned different or various examples of physical quantity, especially the derived quantity. So now we want to see how we can use dimension to determine the dimension and the unit of all those derived quantities. Let's look at example. Example 1. Example 1. Find the dimension of density. Density. Find the dimension of density. Now, let's take this one as A under this one. B, what is the number of times that mass, length, time. Now, from this big question, what is the number of times that mass, length, and time appear in density? Let's add one more question to make it C. And the number C is write the basic unit of density. Now, solution to this one. Solution. The derived quantity given in this question is density. You write it down. Density. Now, if you follow me from our last lesson, the formula for density is mass over volume. Don't forget, this is just the continuation of what we have been doing, and it's a progressive lesson. So, from this one now, we want to reduce this one to the fundamental level of density now. That will be m over length times breadth times height. That's the formula of volume. Now, don't forget, we are familiar with all this from our last lesson. Now, the difference we are going to have here is that this is mass, m for mass, l for length, b for breadth, and h for height. And what we are looking for here is, we said, dimension is the power to which the fundamental unit of mass, length, time, temperature, heat must be raised to represent physical quantity. Now, we need to relate all this one to fundamental quantities now. And the fundamental quantities that were involved here are mass, length, and the last one is only mass and length. Now, what is the dimension of mass? The dimension of mass is capital M. That of length is capital L. That is the dimension of mass and for length. Now, under this topic now, you need to take note of this one, that when you are writing dimension of any quantity, it must be written in capital letter. Now, note this my M now. You can see this my M is very big, but it's very small letter. But look at this my M. Although it is small, but it's capital letter. So when you are dealing with dimension, I want to write dimension of any quantity, that must be written in capital letter. Take note of that one. Now, since we said the fundamental quantities that dominate here are mass and length, then the dimension of density will now be dimension now will now be capital M for mass over capital L for length. The same breadth will be equal to length. So that will be L again. H will be related to length. That will be L again. Then we are going to have N over L cube. Now from there, apply law of indices. Because from law of indices, this one will give us M multiplied by 1 over L raised to power 3. And 1 over L raised to power 3 in indices, the dimension of density will now be written as M L raised to power minus 3. That's the dimension of density. Now, according to the definition of dimension now, and according to the question given to us, that the question says, 1, find the dimension of density. We should find the dimension of density. So we've seen that the dimension of density, according to this analysis, is capital M, capital L raised to power minus 3. Now, from this one now, that is answer to question 1. To answer question 2 now, the question says, what is the number of times that mass, length, and time appear in density? Let's now look at it now. For mass, what's the power of this n according to the definition? That is the power to which the fundamental unit of mass, length, or any fundamental quantity given is raised to. So m, the power of m will be equal to 1. For length, the power of L will be equal to what? Minus 3. Now, you can now see that time is not appear in density. So you can now say for time now, it will be equal to 0. So to rewrite this one, it will now be m L raised to power minus 3 t raised to power 0. That will be the from question number B. That is the power to which the number of time that mass, length, and time will be appeared. Now, to answer question C now, this is A question, this is B question. To answer question C, you can now see that if you follow me right from our last lesson, write the basic unit of density. That is from the first application that we can write the dimension and the unit of any physical quantity. This is the dimension now. To write the unit now, what is the unit of mass? Kilogram. The unit of length? Meter. So it will be kilogram per meter cube. That's it. The dimension of density is this, and the unit is this. And that's all for that. We've answered the question now. And if you still have any other question based on this one, as I always say, don't forget to subscribe and ask your question in the comment section. Thank you.